I'm a principal consultant with Viscosity North America. We're a full-service Oracle Platinum Partner and the 2019 Oracle Database Appliance Partner of the Year. And my role with the company, I help customers with a lot of rack and maximum availability architecture implementations. I work a lot with engineered systems, diagnostic tools like Autonomous Health Framework and Trace File Analyzer. And I have a rather deep background as an operational DBA and database reliability engineer and architect. And I try to leverage that to build a lot of automation, particularly when it comes to upgrades and migrations and cloud implementations. And that includes working with Docker and containers. I'm also an Oracle ACE, and if you're not familiar with the ACE program, it recognizes members of the Oracle community for their technical contributions to Oracle technology. So if you or someone you know is active as a presenter, as a blogger, or working behind the scenes in a user group to put on events such as this, I would encourage you to nominate them or yourself at this link over here in the bottom right-hand corner. Oh, I'm not sharing my screen, am I? That's not very helpful.
Not yet, but okay.
There we go. At this link down here in the bottom right-hand corner. As I said, it's still early in the morning for me here. All right. So this is a workshop style event, and I really encourage everyone to ask questions. Don't feel bad about interrupting me or anything like that. I'm used to it. I do a lot of demonstrations in this session because I really feel like showing people how Docker works and how fast and easy it is to use is a lot better than putting up a slide and saying, Docker is fast or Docker is easy. So I want to offer everyone the opportunity to follow along with the lab exercises and demos if you would like. It's not necessary by any means. You can watch what I'm doing. I'll make the presentation available for you to download. All of the commands that I'm running are in the slides, and they're available to download. So you can play and experiment with things at your leisure. But if you would like to follow along, there are 3 things that you're going to need. The first is the Docker desktop engine. And you can download this for free for Windows or Mac, or also for the Docker engine for Linux. And I put these links into the webinar chat as well. So that's the first part. The second thing, you'll need to download the zip file, not the RPM file, but the zip file for Linux x86 64 for the database version that you'll want to have running. In this case, all the demos that I'm doing today are based on the Oracle 19c download, so the 19.3 download. And then the final piece, I like to have a directory on my machine. I typically use Docker out of my home directory, so I'll make a directory where I'm going to pull Oracle's GitHub repos. And if you're not familiar with GitHub, don't worry about it. You just go to this link here, this github.com/oracle/Docker images, and you can just download this repo. You see it up here in the, you'll see this clone or download link here, and you can download the zip file and bring that onto your machine. I'll cover all of how all of this works a little bit later in the presentation, but because there's some downloads involved in this, if you do want to follow along, feel free to go ahead and do this part right now. Then once you have that, that repository downloaded onto your machine, you're gonna get this real long directory path here, and I'll highlight it. You're gonna get this real long, cool directory path here. And that Oracle database installer file that you downloaded, the zip file, drop it into this Docker images Oracle database single instance /Docker files /19.3.0 directory. You don't need to unzip that file. Docker will do that for you. And that's all you need to run an Oracle database on Docker. So great, we're done. All right. So I started running Oracle on Docker about 7 years ago. It was entirely against my will. I'd heard all sorts of horror stories about Docker and working with Docker, especially when it came to Docker and databases. And as I started working with the database, again, entirely against my will, I realized that all these stories that I'd heard from folks, all this doom and gloom and so forth, were coming from a lot of the same people who cry foul about anything new. And it turns out these were folks that didn't really understand Docker very well. And then I noticed that they were very familiar. They sounded a lot like, I don't know if all of you are as old as I am, but when RMAN first came out, there were people who said, oh, no, I'm never going to use RMAN. It's not very trustworthy. It'll never replace real backups where I go in and I set my table spaces into backup mode and all of that. And then we had databases where we added advisors and automation, and very respectable database administrators and professionals in the field said, no, there's no way that all of these advisors and so forth can possibly tune memory or assign rollback segments or manage undo segments better than a real DBA, a human DBA can do. And as virtual machines, same thing. Very similar voices, very similar stories. Never run a database on a virtual machine if you want to have any kind of performance. And more recently, we hear this a lot with the cloud as well. People playing it off as a fad, even to this day, just a different way of marketing a data center and so forth. So for anyone who says that Docker isn't suitable for databases, Oracle does support Oracle does support running an Oracle database in Docker as a single instance. Their limitations are that it has to be on Oracle or Red Hat Linux. They also support RAC on Docker in non-production environments. They don't support it in production environments, at least not yet. So it is a supported solution. It's there's no reason that you can't use it. I have actually used it in some production environments. I know several customers, several sites out there that are using that are running Oracle on Docker for production use. So if you're not familiar with containers and you're not familiar with Docker, what I want to do is cover some concepts so that you can get a better picture of what Docker is, and more importantly, what containers are and how they work. And this is something that I really wish I had grasped better when I first started working with Oracle databases and containers and so forth years ago now. And perhaps the most important step toward really understanding what containers are is to know what they're not. And you may have heard people talk about containers and say, oh, containers are like lightweight virtual machines. And they're not. They're not virtual machines, not at all. Now, it's really understandable that we might compare containers to virtual machines because they let us do very similar things. But I see and I read a lot of analogies where people say, oh, containers are like X and virtual machines are like Y. And they're usually things like containers are like cars and virtual machines are like trucks. Virtual machines are like houses and containers are like apartments. And these things tend to make containers sound less powerful or less capable or less serious and production ready. And that's not the case at all. So I could show you some graphics where I illustrate, these are the different layers and so forth. You've probably seen these a couple of dozen times. They're all over the internet. They're on Oracle's site and Docker's site and so forth. And you can compare virtualization and containers side by side. But what I want to do is I want to show you what a container is and how it is different from a virtual machine. And so to do that, I'm going to create a container on my command line from scratch, not using Docker or anything like that. I'm just going to show you how a container works by doing nothing more than running some commands on a Linux command line, not in a virtual machine. Well, actually, it is in a virtual machine because I'm going to do it on an Oracle Cloud Freak account on a Linux compute instance. So let me switch over here. So again, this is an Oracle free tier, an OCI virtual compute instance running on the Oracle Cloud. And I've just CD'd into this directory docker/alpine. And in this Alpine directory, what I've done is I downloaded a copy of the Alpine file system, or Alpine operating system. And Alpine, if you're not familiar with it, is just it's a very lightweight, small implementation of Linux. And so I pulled this, I did a wget on this tar.gz, and then I decompressed it here. And so if you look at the contents of this tar file, you see it looks like the root directory of a regular Linux operating system. So I've got bin and dev and etc and home and so on and so forth. So now I'm going to switch over to this other window. This is the same machine. It's just a different session on the same machine. And you see that I'm in the same directory. I'm in this Docker Alpine directory. And I'm going to run this command. Let me show you here in my presentation. So I'm going to run this command here. And this is a command called unshare. And unshare does just that. It unshares some resources for a session running in a Linux operating system. And so I'm going to tell it to unshare several namespaces. And namespaces are just ways, if you're not familiar with Linux and what namespaces are, they're just ways that Linux isolates different types of processes. So one of these is the mount namespace, and that's just how I mount files. The user time space, PIDs, which allows me to have my own processes, fork, which allows me to fork processes, user space, which means that I'll be able to have my own users in this unshared session that I'm starting, IPC networking. And then I'm going to map my root user and its directory. I'm going to change the root directory to this /docker. Well, this didn't manifest very well, but this /docker/alpine file system. And then I'm going to start a shell session called bin ash. It's just the bash shell for the Alpine operating system. So here you see this is that command, and that's not going to work because I've got that extra space there. Hang on, let me just pull a better looking command off of out of a. It's good when you see that your demo isn't going to work. Bear with me for just a second. Where's my command? Here, let me just do this. I'm going to copy this out and rewrite it. This is why you don't do live demos in presentations. I tried to format this so that it was nice and readable for everybody, and obviously that failed. I was doing this very late last night. Here we go. Okay, so this command is not going to work. But now if I run that command, there we go. So I've run this command. I had this. This directory was was not mapped out correctly. So now you see my prompt changed. And if I do some things here, like I echo my session, you can see that my PID is 1. I am process number 1 on the system. And if I do who am I, you see that I'm root. But if I go back over to this session and I say who am I, you can see I'm Oracle. I was Oracle in this session here as well. In fact, if I exit out of this and and I do who am I, you can see that I'm the Oracle user. If I rerun this command back here, who am I? Now all of a sudden I'm root on the machine. And that's because I've isolated my session into what is essentially a container. It's this isolated process running on my machine. So I don't have any virtualization running on my host. I don't have a hypervisor or anything like that. This is not a VM that this process is running in. And you'll see that I can do some kind of cool things. So I can say host name, and you can see that my session comes up here and it says that my host name is ChatOps. But if I do, because I'm root, I can do host name, and I can change my host name to Alpine. And now if I type host name again, it's Alpine. But if I do host name here, you can see that my host name is indeed still ChatOps. Now I can do a lot of neat things here. I can mount my own file systems. In fact, if I do this df to see what my file systems are, you see I don't have any file systems on this system. That's because I don't have yet a process directory where I can actually mount things. I can add that. I can do all sorts of things to make this look like a regular Linux operating system. And for all intents and purposes, if you were to log into this shell this way, you would think that you were running on a completely different system than you were. And this is what a container is. That's all that it is. It's just this isolated process running on a machine that runs the file system that you saw right here. So it's running commands out of this set of directories. In fact, you'll notice that if I go here and I just do an ls, I've got this ash available here in my home directory, in my /bin directory. And if I go here, oops, there we go. You can see that I have a far larger set of binaries available to me here, but I do not, I'm sure, have ash in, yeah, indeed, I don't have ash in my Oracle Linux. And that's another cool thing you can do here. You can do this. So here on this machine, you can see that I'm running Oracle Linux, but if I go over here and I do cat etc OS release, it says I'm Alpine Linux. And that's because it's running, this process is running with this, switch back here, with this Docker Alpine directory as its root directory. So everything runs from here. So from here, I can do all kinds of cool things. I can fork processes and I can run all sorts of different things and make all of those processes think that they're running within this different file system. And what's really neat about this is because it's not virtualized, I don't have a hypervisor. I don't have any extra processes running on my host. I don't have to have a full file system. In fact, you saw with that Alpine file system that I had that I didn't have a lot of the binaries that in my /bin directory that I would have in Oracle Linux, for example. And so I can make that container process very small because it's running in that little isolated file system. And this is what a container is. It's just a process running on a Linux host. And all that Docker did, containers have been around for a long time because all of these capabilities have existed in Linux for years and years and years. What Docker did is they just built a set of tools around all of this that make building and running and managing containers a lot easier than typing out unshare mount pid uts and so on and so forth. Now, obviously, this is a really watered down example, but hopefully I was able to illustrate a couple of things for you. One was I downloaded this Alpine Linux file system. In Docker, we call that set of files, that file system we're running in, we call that an image. and it's like a gold image. It's a snapshot. You could also liken it to a Vagrant box, where you're going to download a Vagrant box and pull it onto your machine, and then you run that Vagrant box as a Vagrant machine. And all that an image is a tar archive that has a list, it's got all of those files and so forth that you need to run. And that becomes a starting or reference point for running a container. So that process I started using Unshare, that's a container. It's a running process. It's running on my host. And from inside that process, it looks like it's an Alpine Linux distribution, but it's sharing all of my kernel resources from the host. So it's not a complete Linux operating system. And that brings us to, sorry, it doesn't quite bring us to, but if you're interested in this, and it really is a fascinating topic, there are some resources out there. This Linux containers and 500 lines of code is out there. It's like 520 lines of code. It's not exact. This Docker and 100 lines of bash, it's like 110 lines of bash, I think, last I checked. So these are really interesting things if you want to learn some cool stuff about the Linux kernel that maybe you weren't familiar with before. These are some neat resources to go to. And then I've got some videos on, I have a YouTube channel, so you can just search Oracle Sean on YouTube, and I've got some videos on Docker internals and running Oracle on Docker specifically. So I was saying that because there's no virtualization, I don't have a hypervisor and then a full operating system installed on top of that hypervisor that I'm using to run that virtualized guest. My container is going to be really fast. You saw how quickly that prompt came up when I did that unshare command. It just, boom, it ran. Because it's running on that local host. It doesn't have to initialize anything. It doesn't need to boot an operating system. So containers are really, really fast. So again, I can tell you, yeah, it's really fast. But unless you see it, I don't think that you can really appreciate how fast it is. So I'm going to run a couple commands here. This first one, all of the Docker commands are preceded by Docker. So the first thing I'm going to do here is I'm going to run Docker images so that I can see what images, what things I've downloaded onto my machine. And you can see here I've got some Oracle Linux. I've got a DB2 that I'm running for a project here, but I don't have Ubuntu. So let's run an Ubuntu container here. So this is a Docker command. I'm going to run in interactive TTY mode. That's the -IT option, Ubuntu. So I'm going to tell it I want to run Ubuntu and I want to start a bash shell. Okay, I couldn't find the image for Ubuntu locally, so it's going to download Ubuntu. And there we go. Now I have Ubuntu running on my machine. So if I do, there, that's Ubuntu. But I'm running, this is all running on a Mac, or at least this session here is running off of a Mac. So I have Ubuntu now running on this machine. And if I go back and exit back out to my command or my command line and do Docker images, you now see that I have this Ubuntu image. And it's 73 meg. That's it. That's all that you need to have an effective Ubuntu installation. Now, it's not a full Ubuntu installation because it doesn't have things like curl and so forth. So you saw how quick it was to get an Ubuntu shell running when I didn't already have it on my machine. But if I rerun that command, watch how fast this is. There we go. That started an Ubuntu machine. Now I have a little lab box that I run on my desktop that runs Ubuntu, and it doesn't boot up that fast. And it's actually a pretty powerful little box. So Docker's a really great tool if you want to be able to go in and have lots of lightweight, fast running environments available to you. And having shown you how quickly Ubuntu starts, let me show you how quickly a database starts. Now you can see here that I have, this is a list of containers that I have running on my machine. And so I have this Oracle 193 container. This is an Oracle database. It's currently stopped, so it's been down for 3 weeks. And so I'm going to run this docker start command, and then I'm going to string it onto this docker logs command. This logs-f just tails the logs from my container. So I'm going to tail the logs for this 0193, and I'll start it. And you see there's my listener starting, and it's connected to the database. And any moment now, this is why you don't do live demos yet again. Oh, come on, don't fail me now, guys. I hope I didn't remove something from this. There we go. So you can see that at least I didn't have to go through the process of booting a machine and so forth. So this is an Oracle database. This is an Oracle 19.3 database that is running on my local laptop here. And it is really slow today. It normally starts up in about 15 to 18 seconds. So I'm going to say there's something going on in my background here. All right, so containers are fast. So there are a couple of concepts that I want to touch on. And the first is stateless, and the next is stateful. And one of the reasons that people will say, well, you can't run databases on Docker is because Docker and images are stateless. Stateless meaning you can't change an image. And an example of that is, well, that's not actually an example of that. So images are stateless, which means I download that image, that Ubuntu image, and I can't change the image. Now I can change the container. So let's go back to that container. There we go. Hey, look at that. My database started. Woo. So here I am in this Ubuntu container again. Remember, this is the one that I started just a little while ago. And if I were to try to run curl and curl Google, it says, oh, curl's not found. So I'll apt-get update. If I could type. So I'm going to install curl here on my local machine. I'm sorry, in this container. Yes, I'm going to go ahead and install that. Oh, look at all that great stuff that it takes just to get curl so that I can curl Google. And there we go. Now I've got curl installed on my container. Awesome. So I can change my container, but if I exit out of this container and I rerun the same command. Now, I'm not going to get the same container. When I exited out of that container, that was a process on my machine. That process ran. When I exited, the process stopped. So if I rerun this command, I'm going to get a completely different container. So this is not the same container. It's going to run from the same image, which is the Ubuntu image. So it's going to say, oh, you want me to run an Ubuntu container. So I'm going to look at this Ubuntu image. It's got a file system on it, right? And I'm going to start that image as a brand new container. And when I do that, starting a brand new process, if I do curl google.com, I don't have curl in my image. So that image, what use is it for running something like a database? If I want to put data, so I start my database container from a database image, right? and I go and I add a bunch of data to my database, and then I have to stop my database for some reason because I want to restart my machine, whatever it may be. If I restart that container, or if I restart that database, where's my data going to be? Okay, good question. And that comes to containers being stateful. Now you saw that I can change the contents of a container. And in fact, if I run this command here, this is just a shortcut. So this is, I ran this command, docker ps-a. And this is really ugly, so I've got this formatted shortcut that I use called DPS. It just makes it a little bit easier to read and everything. So you see that I ran 3 different Ubuntu containers here, and you can see that all 3 of them are stopped. This is going to be the one here, and Docker gave it a name because I didn't assign it a name. This is going to be the container that I ran my apt-get to install curl in. And so now, if I docker start that, and then do docker exec, now I'm back into this container where I installed curl. And in fact, you can see that I've got history in this container. This is just my command line history. And so if I curl Google again, it's installed here. So I can make changes to a container, and those changes are going to be saved in the container state. And until I remove the container by actually deleting the container, even though my process stopped, remember I had this container running, I installed curl, I exited out of the container, so it stopped. I started a brand new one from that Ubuntu image. But when I came back to the container that I had, all of the work that I did there was all preserved. So until I actually delete this container, its state is saved in Docker. Now there's another cool trick for saving information outside of a container, and that's what's called a volume, or a Docker volume. And we'll see a command for this a little bit later, but you saw here that I issued a couple flags here on the command line. There's a flag called the -v or --mount flag that lets you mount a file system inside your container and associate it or map it to a local file system on your host. And this is kind of like having an NFS mount. Both the host and the container can read and write to that directory. And here's the really cool thing. Remember I said that if I were to delete or remove this container that I've got curl in, it's gone, and it's gone for good, right? But if I put information into a volume and save that information onto my local file system, even if I remove the container, that information in that local file system, it's all preserved. And that's going to come in handy in just a little bit. I'm going to show you a really, really neat trick for working with Oracle databases and Docker in just a little bit. So one of the things that I was told when and then this is the reason that I really want to illustrate this, is that I've heard this a few times. When I first started using Docker and containers, I was told, no, you can't use Docker for databases because they lose data. And this is based on that idea that, well, you have a stateless image and a stateful container, and folks were confusing the two and saying, well, I can't save information into an image, so I can't use it for a database. And that's not true, because you're gonna save all of that in the container, and when you're working with an Oracle database, you're going to be saving this ideally into a separate volume so you can preserve that data. So again, if anyone has any questions or anything like that, feel free to drop them into the Q&A or drop them into the chat window. Okay, so what are some reasons that we would want to run Oracle on Docker. And there are a lot of reasons. First is Docker is portable. So I can run Docker on Linux, I can run it on Windows, I can run it on Mac. Container or images themselves, I can move them between systems. They're versionable. Containers are an open standard. So the images I build on my Mac, I can share with people on any other operating system. So I can build a Docker database image on my Mac, share it with someone who's running on Windows. They can pull that image onto their local machine. They will get exactly the same experience from their running of that image as I get on my Mac, as I get on a Linux machine, whatever it may be. And this also means, of course, that images are distributable. So a good example of how you might use them is you build some images in your environment, you put them into a repo in your company, and then you can have developers can go out and they can pull those databases, those database images, or Nginx images, what have you. They can pull those onto their local machine. They can run them. They're going to get a very, very reliable, identical experience, no matter what their host operating system is. And that means that I can run an image on Windows, on Macs, on Linux. I can run it in Docker. I can also run it in Podman, which is a Docker alternative that runs containers rootless. It's used a lot in production environments. Everything is just completely compatible between the two. I can run that image in Docker Compose. I can use it in Kubernetes. I can import that image into OCI or Azure or AWS or anywhere else that is using the open container standard, including Tony's Discount Mega Cloud. If they're using a Docker compliant or the open container implementation, it's going to work there. So I can move these containers anywhere that I want, and they're going to work, which is great. But for us, for running Oracle, that's the why. For running Oracle, there are just a ton of things that you can do. And they're mostly things that you might do on your desktop, on your local system. So you can eliminate all of the dependencies that you might have when you're building things. I use it a lot for testing PL SQL and testing scripts and testing SQL scripts and so forth. Hacking on things, experimenting with things, learning new stuff. You can do performance tuning, troubleshooting things without having to build tons and tons of infrastructure. I have a whole session that I do on how you can use Docker to test out how you run upgrades. So you run a Docker installation with 2 Oracle homes, a 12.1 or an 11.2 Oracle home and a 19c Oracle home, and see how you can upgrade between the two. I build labs and training environments and so forth. There are a few things that Docker isn't great for. Enterprise Manager and Autonomous Health Framework, or TFA, are difficult to run on Docker because they hard code host names into their installation. So they're not elegant solutions. You can certainly do it. I've done it, but they're not easy. Rack and ASM, you'll probably find it easier to run those in a virtual machine. At least I find it that way. But you can do them on Docker. And DataGuard is something that Oracle will tell you that you shouldn't. Definitely not for production. I have a I have a DataGuard repo that runs Docker for DataGuard. And when I announced it on Twitter, I was messaged by one of the PMs saying, no, you can't do this. People are going to think that you can run this on production. I said, no, I've got disclaimers in there so that people know this is just for lab and testing and so forth. So it is cool. It's neat if you want to be able to have a DataGuard environment that comes up and is available to you in a couple of minutes, all pre-configured and so forth. But it's not an ideal, it's not a simple implementation. So those are some things that it's not great at. All right, so we got a lot of background out of the way. Let's start running some stuff on Docker. Yay, it's about time. Sorry, I use a lot of GIFs in my presentations. So again, we covered this at the very beginning. All that you need are three things. Get that Docker desktop or Docker engine for your operating system. You download that. There are some container registries available to you. I didn't talk about these at the very beginning. There's an Oracle container registry here at container-registry.oracle.com. These are official images from Oracle. And these same images are available, I think they're the same images, available at hub.docker.com. These are Docker certified, verified publisher, official image containers. And your options are Oracle Database Enterprise Edition 12c. That's what you can download. But Sean, what if I want more than just 12c that you can get in the Docker Hub or the container registry? Well, that's why we went and we pulled this GitHub repo that I mentioned a little bit earlier. In the GitHub repo, you've got the ability of running 11g, 12cr1, 12cr2, 18c, and 19c. This is 18.3, which you can run as either standard edition or enterprise edition. There's also an 18.4 express edition, and then 19c, which is the 19.3. So these you have to build yourself. And that scares a lot of people. They'll say, oh no, I don't want to have to build it myself. That's going to be time consuming and painful and difficult, and I don't want to learn new stuff. And really, there's not that much to it. Please, however, do not be tempted to pull someone's pre-built database image that they put in a blog post. And there are a shocking number of them out there. Two reasons. Any pre-built Docker image that is using a standard or express edition, I'm sorry, a standard or enterprise edition of Oracle, if it's already installed, it violates Oracle's licensing agreement because you're not allowed to distribute or redistribute those files. But it's also a huge security risk. Remember, you're using this image to run a container, and running a container is essentially inviting that code to run in a privileged state on your machine. So if you're pulling an image, that is that whole file system, remember, if we pull that image, you might as well just be downloading all of those files that you get in email that say, hi, you've won the lottery or whatever it may be. Just open this file and fill it out and so forth. That's the Docker equivalent of downloading malicious code onto your machine. So that's if you were to pull an image, which is, think of an image as that prepared thing. There's a difference between that and the open source code that lets you build your own image. And that's what we're going to look at here. I'm sorry, here. This is the Oracle Docker GitHub repo that I mentioned before. So if you pull this, this is just a set of scripts that lets you build images. So you can look at this code, you can inspect it. It's a lot easier to look at this than look at code or look at an image, because that image, remember, is a whole file system. And some of the Docker images are going to be 5 to 8 or 9 gig in size. That's a lot of things for you to inspect. So don't be tempted to pull somebody's image off of the internet. So this is the Docker GitHub repo. And then remember also, we need one other thing, and that's the actual Oracle database software. So when we download that, we're going to download the Linux x86 64, and we're going to download the zip file. And this is, you're going to download this x86, whatever operating system you're on, Windows, Mac, Linux, doesn't matter. You want to create a repository directory for your repo here, and then pull this repo into that directory, just so that it's easy to find and manage and so forth. Again, if you're not familiar with GitHub, when you go to that repo, you can just do this clone or download and then do the download zip file. You don't need to know GitHub or anything like that in order to use this. If you do, git clone, and so forth. And then finally, you're going to take that, that zip file that you downloaded, and you're going to drop it into the 19.3 subdirectory of that, the GitHub repo that you pulled. And we'll change directory into this Docker files directory or subdirectory of the Git repo that you downloaded from Oracle. And then we're going to build an image at that point. Once you're in that directory, you're going to see that there is a file there called build.dockerimage.sh, and this is something that Oracle provides. And you only need to tell it two things. And the first is the version that you want and the edition. So here we're going to do -v is 19.3.0. In fact, let me find the right directory here, or the right window. I'll just navigate to it. Docker images. There we go. So once you're in this this subdirectory, you'll see there's this build.dockerimage.sh, and you see that there are some subdirectories, and this 19.3 subdirectory is where you are going to put the zip file that you downloaded, and then you've got this build.dockerimage.sh, and that's what we are running right here. And we're just going to tell it this version, and this version is going to be equal to one of these directories. So 11.202, 12.102, 18.3, 18.4, 19.3.0. And then -e, in this case, I'm going to do Enterprise Edition. -s will do Standard Edition. For the 18.4, which is the Express Edition, I don't think that you have to put anything in there at all. I've never built it from this build Docker image script before. Anyhow. And then from there, you just wait. This will take a few minutes. What this process, when you run this script, what it's going to do is it's going to go out and it's going to run what's called a Docker file. And the Docker file is just a set of instructions. It's infrastructure's code. So it says, hey, the first thing that I need is a Linux operating system to work from. I'm going to go out and I'm going to pull an Oracle Linux 7 image. I'm going to pull that down to the local machine. I need some additional libraries. I need the 19C pre-install library. So I'm going to add those. I'm going to add a few executables and so forth. It's going to look in that, the directory. It's going to find the zip file for the 19C installation. It's going to pull that into the image. Remember, that image is a file system, so it's going to effectively do a copy from your local system into that, that file system that it's building for the image. It's going to unzip the install file. It's going to run the installer just like you would normally see. And what's really cool is you see all this go by on the output. So you're going to see everything that's happening there. It's going to look very familiar to you because you'll see all the RPM package installs go by. Then you'll see the database installation. It's going to pause for a little bit and it's going to say, oh, hey, good. We've unzipped the software. Now we're installing it and so forth. So you see all of that stuff happening in the command output. On my machine, this will take anywhere between 5 minutes and maybe 15 or 18 minutes. It just depends on the build and how much stuff I'm doing in the background. Not a particularly powerful laptop by any means. Like I said, I've got a lab machine that I just picked up recently that is much, much faster. It's great. So now that you've got this image built, you're going to see when you go in here, if I do Docker images, you'll see it'll create an image for your database, and you'll see something like this. It'll say Oracle database here when it's done building it instead of Oracle//db. This is my own private repo. And then you'll see this tag, which is just the version, and the EE means that it's Enterprise Edition. And it'll tell you how big it is. So a 19C image is 6.5 gig. And now you have this image, and remember, an image is just a file system. When you want a container, you run the image. So now we're going to run that database in a container. And I think that we are roughly at the halfway point, aren't we, Yanis? Do we want to take a break here? 10 minutes?
Hello. I'm not sure how much do you prepare for us for today? For half an hour or more?
Yeah, I can talk about Docker for 5 hours if you'd like.
Oh,
but I don't think that you would like that.
I understand this. Yes, definitely.
Why don't we go ahead and take a break here? You want to do 10 minutes? Is that good for you?
It could be 10 minutes. Yes, fine.
Okay. Yeah, let's do 10 minutes. And if you have any questions, I'm going to stay here. So feel free to go ahead and ask questions in chat, and we'll take a quick break.
Then I will leave you that you have a screen share, and we wait for some questions and answers.
Okay.
But then we start, let's say, at 3:30 in 7 minutes. It's okay?
That'll be perfect.
Super. Fine. Thank you.
All right. Thanks. Okay, I saw people raise their hands, but am I just not seeing where? Okay, I'm seeing people raising their hands, but I'm not seeing anything where I can respond to you. So if you do have questions, please feel free to just drop them in either privately or to the group in the chat. Or into the Q&A.
If somebody wants to say something from the audience, please let me know in the chat, and I will allow that you could talk with the presenter. Nobody wants to say something. They are just tired and waiting for the end of the day. Here we have Alex. Maybe Alex will talk with us.
This is the virtual equivalent of nobody wanting to sit in the front row.
Yeah, it's in Slovenia is almost always like this. So we are not the people who wants to be very in the front. But I hope that maybe this virtual event will help us on this area. But I see that nothing is better. We still have 41 people here, just waiting for you to talk.
Well, we'll give folks a couple of minutes for a bio break, and we'll come back. You said at 5:30, so at is it 4:30 there or 3:30?
3:30.
Okay.
3:30. And what's your time in your place?
It's 7:30 in the morning right now.
Okay. And you usually come to the office probably at 9, or you work at home?
I work from home.
Okay.
I'm normally remote, so remote with a little bit of travel to customer sites every now and then. But this is I'm usually at my desk around 7 or so. But I tend to have long days. My wife and I are empty nesters now, so there are no kids, and it's really easy to kind of lose track of any schedule. So we both normally will work an early day into the afternoon, and then take the dogs out and let them run around, and then come back and
and
cook.
Work again.
And yeah, and then I come back and do some more work.
Yeah, I'm also familiar with this. We are now, because of the situation of Corona, mostly working at home. But when I'm not at home, I need to drive, let's say, 45 minutes in one direction.
Oh,
but
yeah.
I usually stop work when I'm in the office earlier than I'm stopped working when I'm at home. So it's a lot of things to do all the time. So never you could never stop, but you will never finish. If I say so.
Yeah, it's easy to get sucked in when work and home are the same place, and you just keep walking past. I have a room that's my office, so I mean, I could close the door and say, well, you know, I'm no longer at work. I've driven home, but it's just really easy to look and go, oh, but I've got that one thing that I was going to do, or I'm going to send that email or whatever, and then you sit down, and before you know it, 2 hours have gone by. And
yeah, that's the situation.
Yeah.
Okay. One question we have do you see in question?
I see that. Yep.
Okay, super. Thank you.
Yeah. So Peter, Peter had asked. He said he's been experimenting with the Oracle Docker GitHub repo, and the default scripts that Oracle provides create an image that creates a CDB with a pluggable database, and that he's modified those to just do a non-container database. And he's asking, since some people don't want PDB functionality, is Oracle going to patch those scripts or give you that capability? I don't think that they have plans to do that. However, and there are a bunch of people out there that have their own Docker repos for running Oracle. I have one where you can pass an argument to the build and say, I do or I do not, or I'm sorry, pass a parameters to the container run command that you can say, I want a pluggable database. I want 3 pluggable databases. I don't want to run this as a container database. So I just want to have a traditional database without any pluggables. So there are folks out there that do that. So I don't think that Oracle is doing that, but there are certainly individuals who are doing that. And I'll have a slide at the end of my presentation that has my GitHub on it. But if you are interested in taking a look at what I've got, it's the github.com. And then my username on there is Oracle Sean, all one word, OraCleSean, the correct spelling of Sean. Okay, so we are back, and we're ready to run our database. Remember, we created our image. And so if we want to run a database in a container, this is all that you need to do. You just run this command, and very simply, Docker run. We're going to run the command, and we're going to do this -d, which means we're going to run it detached. And the value of running it as a detached session, or is it a detached container, is you're saying, I want this to run in the background. Remember earlier, we created that Ubuntu container, and when I exited, the container stopped. Here, if we run it with the -d command, it will continue running in the background, so I can attach to the container or run a process in the container. I can drop out, drop back in and out, and the container will continue to run in the background detached from any user process. And then the final thing that I absolutely positively have to give my run command is the name of the image that I want to run. And in this case, this is going to be the default name of the 19.3 image that we created, 19.3.0-EE, because we created this as an enterprise edition image. And that's it. That's all you have to do to run a Docker container. I'm sorry, all you have to do to run an Oracle database in a Docker container. But again, this is the bare minimum. You probably want to do a couple extra things. And everyone's going, oh no, this just all of a sudden got really, really ugly and confusing looking. And really it isn't. There's not a whole lot to this. This is the same here, this Docker run. And this image, this is the same too. I just added a couple extra things. The first is I gave it a name. Remember when we were here, and I ran this Docker. Oh, this is a different machine here. Hang on. So remember here, I ran this Ubuntu container, and I got this wonderful created name. I want my database container to have a reliable name that means something to me, like 18CX. You can probably figure out that that's an 18C database that's running XE, or 0198 is Oracle 19.8. I mean, that makes sense. So we're going to give it a meaningful name in this case, this 0193. This next one, oh, let me just drop down to this last one here, this -E. -E passes an environment variable to the container. So I'm telling the container when it starts that I want to use an Oracle SID of 0193. So now I can create a database container with a database running inside of it, and I've given the database SID a name other than the default, which is going to be ORCL CDB. So these next two are the ones that get people. This probably looks familiar to you, 1521. That's the port, of course, that the listener runs on. And this here, this -P command, excuse me, my throat's drying out here a little bit. This -P command maps a port from my container. So I'm telling it the container is going to be running a process that listens and responds on port 1521. And I want to map that to my local host on port 11521. This is just an open port that I decided to use. And what this means is I can have multiple Oracle database containers running on my local machine, and I can communicate with them on their port 1521 and just map it to a port on my local host. So all the 1521 traffic in and out of this particular container, 0193, is going to traverse on my local host on port 11521. So I can have a bunch of different containers all running 1521, and I can access them on localhost on different ports and so forth. So I can run SQL Developer, I can run multiple databases, and I can have those databases, whether they're containers or VMs or whatever, communicating on my local host on different ports. So I can expose them that way, and that makes them useful, because what's a database if you can't get to it, right? And then this last one, this is what I was talking about before about volumes. And we're going to map a file system on my local machine. So I just told it I want this oradata/0193 directory on my local machine, and I'm going to map it to a directory or file system in the container. And in the container /op/oracle/oradata is where all of my database data files, temp files, control files, redo files, they all go under this oradata. So now all of my database data will be available to me on my local machine. And remember before we were talking about volumes and said that if we were to remove a container, that the container's data goes away. But if we store data from that container into a volume on the local file system, even if I delete the container, the data in that volume remains. That's going to be the case here. And this is a really cool thing because this lets us do some amazing, magical, wonderful things with Docker and containers that I'll show you in just a minute. I know I keep telling you, I'm going to show you that in just a minute. So this is the command to get a useful container, useful database container. And that's it. That's the whole base stuff for running Oracle in Docker. But there are tips and tricks. Now, remember, I created that container. I ran this command here to create this container. And I mapped this local file system to this oradata directory. And there's a cool thing that is unique about the Oracle database builds. And that is if you do a tree on that local file system that I just showed you. So this would be in my /oradata. In fact, let's just go ahead and go here. So you can see I'm here in my local oradata directory, and I've got a bunch of different things here. So let me just cd into 0193, and you can see I've got this Oracle CDB, and I've got dbconfig. And if I tree on this is my output. So this all looks really familiar right here. You can see all of that is what I would expect from a database running in an Oracle database running on a local file system. But this is different here. You probably never see this dbconfig command outside of Docker. And you'll see that I've got this dbconfig directory, and then I've got a subdirectory for my SID, and then my listener and my password file and my ORA tab and my SP file and TNS names and so forth. They're all here in this oradata directory. And this is saved on my local machine. So this makes it so that not only do I have all of my data stored outside of my container, I've got all of my database configuration stored outside of my database container. So if I remove my database, I still have all of my data and all of my configuration. Okay, so you're thinking, okay, so that's cool, that's great. So what? What good is all of that information outside of the container if you don't have the container? Like, say you've removed the container. I don't quite get the point yet, Sean. Well, here's what you can do with that. So this is how I originally created my container. And I said, I want my data to be here, which means all of my database files are on my local file system in this /0193 directory. That means I have a gold image of my database, doesn't it? So if I start a container, when it first starts, it's going to create a database. Remember in my run command, I gave it an Oracle SID. So I said, I want to have a database called 0193 or make IT or whatever I want that SID to be. So the very first time I run my database, it's going to run the database configuration assistant. It's going to start up. It's going to create my database for me. It's going to populate all that from seed the way that it would normally create a database. When it's done doing that, I have a database. If I stop and start that container, when it starts up again, it's going to look, it says, do I have a database? Oh, yes, I do. Look, I've got this oradata directory and I've got configuration files and so forth. So I'm not going to create a database. I'm going to start a database instead. It's got that logic built into it. So now I've got this database here and all of my data is here. So if I go in there and I make changes to my database, it's all persisted there. but I've got a gold image of my database at this point. I can copy that to a brand new directory. This is where that volume command comes in handy. And you can see here that if I cd back one, I've got this directory here called clone. So I've already done this in this demo and a couple other sessions. But if I copy that data into clone, and then I run almost the same command that I did before. The only thing that I've changed here is I changed the name of my container. I changed the port that it's mapping to, and I changed the directory that the volume is referencing. I'm going to use the same image, because remember that image is the file system. You end up with this really cool capability. And let me just, let me find this command in my notes here so you can see this in action. I don't have that. Okay, hang on just a second. Bear with me for just a moment. So what I'm going to do here is I'm going to talk and type at the same time is what I'm going to do. Okay. So let me show you what containers I have running on my machine. You see that I do not have a database called clone. So I don't have I'm sorry, I don't have a database. I don't have a container called clone. So I don't have a container called clone. I'm going to start a brand new container called clone. So I'm going to run this Docker run. I'm going to run it detached -- name clone. So I'm going to create a brand new container. I'm going to map to the same ports. I'm going to map to this different directory, and I'm going to map it to that Aura data. And I'm just going to pull this. This is the image ID. I can use either the tag. So this is a tag, RPM build. I'm sorry, Oracle Linux 7 Slim. That's a tag. In this case, I'm just going to use this this image ID, and then I'm going to do Docker logs -f clone. So that, remember, this is a brand new container. So this container doesn't have a database, or at least I haven't created a database for it, but I'm pointing it to a copy of data from another container. And we'll just look and see how this runs. So listener starts, it sees at this point that I have a database instance out there already, and it's just going to start it. So I've effectively, because I've got a copy of my data, I have a virtually instant database. So if I want to just create, say you've got a QA team, right? And your QA team needs to have a gold image of data that they start from. And then they're going to go through the QA process and run all of their scripts and validations and whatnot. If you have this gold image of your data, well, now your QA team can go out there, they can pull the image to their local machine, they can pull that data copy to their machine, they can start their database container from here, they get an instantaneous, I realize that today my machine is not being as instantaneous as I would like it to be, but at least I don't have to build the database here, right? But you have a virtually instantaneous set of data from which you can work. And so we don't have to go through the whole process of building the database, which means I can also take backups of my data this way, and I can destroy and recreate a database container from that gold image if I need to or if I want. So this is a really neat trick that you can use for building databases, for copying databases, and for distributing data. I did something like this with a company that I worked with in the past, where we had a huge dev team and we had a huge QA team. It was an online commerce environment. And we needed to distribute data out to different people, and we had different sets of data. And so they could just point a container at whatever reference data set they wanted and run it. And everybody knew that not only were they running a known quantity in their database, but they also had a known quantity of data to work from as well. So really, really neat trick. The one thing that you want to watch out for with this, though, is that you don't want to just put everything from all your database containers in the same place. Because as you may have noticed, let me find the right window here. I think it was this one here. So you see I've got a system and sysocs and control files and so forth. If I didn't put all of these in unique subdirectories, then I would have multiple containers all writing to the same control file and system.dbf and so forth. And that's bad. You don't want that. All right. There are some things that you can do to customize your database creation. You remember I passed that environment variable, that -e for the Oracle SID. There are these other options that you have. So you can give it a password. It will create a password randomly for you if you don't do this. So you don't need to pass any of these things. There are defaults for all of them. But should you want to give them these values, you can. So they include the password, the SID, the PDB name, the character set, and the time zone. So these are all available to you. A couple things that you want to look out for. If you have a bunch of containers running on your system and you leave them running for a long time, well, it's Oracle, and Oracle writes a lot of logs. Eventually, they will, and I say eventually they will write enough to fill up your file system, depending on the size of your file system, obviously. So a couple of things that you might want to look for are just to go in and every now and then, just make sure if you've got anything long running, just go in and remove these old audit and trace files and any core dumps that may have been generated. The Oracle Docker containers run in no archive log mode by default. So you don't need to worry about your file system filling up with archive logs by any means, unless you were to activate that feature, in which case you'll know that you have that set and you'll know that you need to go and clean them out. But these are the things that you do want to look out for if you're running something in your environment. And again, this isn't something that's going to fill up your file system within hours or days or even weeks. This is more like after having run multiple databases for a few months on my local laptop, eventually things started acting weird and I realized, oh, I filled up my file system. Good job. If you want to connect Docker to SQL Developer, an Oracle database running in Docker to SQL Developer, remember we passed or we mapped that port. We'll just use that port as the port, and we'll use localhost as the host, and then whatever SID. Oracle CDB again is the default for your service name, but you can give it something else. And look at that, I've got a really long complex password there. It's probably 11111111. So you can connect SQL Developer, SQL CL, command line tool, all of those things from Docker. And you can connect multiple databases running this way as well. There are ways for you to go in and customize Oracle's build scripts, and I'm just going to touch on those real briefly here. Let me find the right window. Let's just do this. Oracle database. Okay, so if you go into the version subdirectories, this 19.3 in this case, and you do an ls, you'll see there are some .sh scripts here. And the ones that you want to look at if you're interested in modifying things are going to be this create DB. So this is the script that creates the database itself. This install binaries, which installs the Oracle binaries. and then run Oracle and set up Linux. Now this setup Linux env is where if you want to add additional RPMs to your build, you can do that here. So say you want to have VI included or strace included in your Docker build, you would add that here. You can, as I think it was Peter was talking about, he said that he modified those scripts so that he could get a database that ran a non-container database. That would have been here in this run oracle.sh script. And it's just a matter of going in and, in fact, if you look at this run oracle.sh, I thought it was here. Oh no, it's in create.db. Sorry. I thought it was here. Where's my run installer command? Oh, it's dbca. Sorry. I was thinking run installer. So you can see right here that all that it's doing is just running this this dbca command. So it's there's no magic or anything like that here. And in fact, it's calling a response file. So you can this is a template of the response file. And what Oracle is doing here is they're putting some boilerplate text into the response file. And then when it creates a database, it reads these environment variables that are passed to the container and it replaces them here. So we're just doing Oracle SID. And what you would do is just change this template here from the create as container database from true to false if you don't want to have a container database created. So there's a lot of neat, cool stuff that you can do in here if you want to adjust and modify these scripts. And I'll leave that to you to experiment with and play with and discover on your own. I've got a lengthy command reference here if you're interested. And this is all part of a slide deck that we'll distribute for the presentation. But this is just a handy command reference. These are the commands that I use most often for, here we are, running a container, starting and stopping a container, removing a container. So if you've got a bunch of containers on your system, like I always seem to have, then you can remove them. Removing images. So if you're done with an image, like when I'm done with this session here, I'll go and I'll look at that that list of containers that or images that I have for Ubuntu, and I'll remove those because I don't need them anymore. I can always pull them for the next one. Looking at the logs for your containers. This is one that I didn't cover explicitly, but if you want to connect to a container, remember that I started or I ran an Oracle database container and I ran it in detached mode. If I want to connect to that and get to a command shell on that container, I'm going to use the exec command. And in this case, I'll run docker exec and this IT, which is the interactive TTY method. And then I'll give it the container name and then the word bash, the command bash, and that'll drop me into a bash shell in my container. So I can do stuff. If you want to connect as root, then you can add the -u for user root. And sometimes there are a couple of the Docker images that Oracle has that this won't work. It'll give you an error. And it's because it'll say root doesn't have a working path. And if that's the case, then just add this -w and give it /root or /Oracle home or whatever you might want so that the container will start at an appropriate point. You can also run commands without actually having to go into the container. So I can run this docker exec IT container name bash and then a -c and then in quotes give it a string of commands, one or more commands. So if all you want to do is get some input or get some output rather from your container, you can run this, run your command, and you can run SQL Plus from here if you want. And in fact, I think that's on the next slide if I'm not mistaken. Yeah, so you can run SQL Plus directly from that. There's a script that Oracle provides for changing the password. So this is a cool thing. Say that we've gone out and you create a database container and then you add a bunch of stuff to it and you're like, oh, I've customized this container and I've done a bunch of stuff. I wish that I could save this to a brand new image so that when I want to run another database container, I'll already have all of these extra things, all of these modifications and customizations that I've done. I want to have those available to me, and you can do that. And that's with this Docker commit command. So we'll do Docker commit, and then you give it the name of the container that you want to save. It can be running or not, doesn't matter. And then you'll give it the new image name that you want it to have. And now you'll have a brand new image that will be an exact replica of the container at the point where you ran the commit command. So if you added, earlier when I added curl to that Ubuntu image, if I wanted to have an Ubuntu image that always had curl in it without having to reinstall it every time, I would commit that to a brand new image, and then I would run that image, and all the containers that ran from that will already have curl installed. This is just a quick creation reference for you for running that that build Docker image command. So these are your options for the edition, and these are your options for version. How to create a simple image, how to run a container, mapping ports, mapping volumes. These are, again, this is just a reference. A lot of these were the same ones that we hit on before. And that's it. So does anyone have any questions? Y'all going to go out and create databases on your machine? By the way, I have, this is a Mac laptop that I'm running on, and I have had 9 Oracle databases running in containers of various versions running simultaneously on my laptop. So it is a very resource conservative way of running Oracle databases, much better than virtual machine is for that. Okay, so I've got a question here. Successfully paired Oracle DB and Docker with having a data directory on a Linux BTRFS file system, copy and write, able to create clones, multi-terabyte database in an instant. Yeah, cool, very cool. Yeah, so there are all kinds of neat things that you can do with Oracle and Docker when it comes to making things available. With Docker, I can, one of the things that I'm experimenting with my builds right now is to have Docker volume for saving my Oracle homes. So with 19C, you can have read-only homes. So instead of every container having its own Oracle home, just having a single volume out there so that I can have containers that reference that read-only home, and then their configuration information is stored locally in the container. So it makes for smaller containers, and it makes for faster builds and things like that. So there are a lot of neat, cool things that you can do out there. There's a question here. Any use cases for running large high-load databases inside Docker? Any real-life experiences using large high-load Oracle databases inside Docker? I don't have any personal experience running high-load databases on Docker. I don't know of any reason that you can't do it. Remember again that Docker is just a process running on a host. So if your host has the resources and the capability of running that load, then presumably your container will have that capability as well. Now, again, we get into a situation that is somewhat like you might have in a virtualized environment where you could potentially over-provision your machine. So the caveat on that would be that you wouldn't want to have lots of high-load databases running in containers where their capabilities exceed the capability of the machine. There are ways in Docker that you can allocate resources at startup, which go a little bit beyond the capability or what we're discussing here in this presentation, a little bit more of an advanced topic, but you can certainly limit the resource consumption of a container or grant that container a lot of resources. So I don't see a reason that you can't run high load. I have heard of people running high loads. And I've tried to get folks to cooperate and co-present and do a presentation where we talk about running production Oracle in Docker. And for the most part, those folks either don't want to share that information publicly, or they don't want to share the fact that they're actually running their Oracle database on Docker. So there is a little bit of stigma still surrounding, but I don't see a reason that you couldn't do it. So next question, do you see any performance penalties of using Oracle database inside a container or Docker? Any bugs or unwanted features? If you're running your database in a container in a default sense, you will have limits, the default limits placed on the container. So yeah, you could run into some situations there. That's really just knowledge of how to tune Docker and so forth. So if you've got folks on maybe in your infrastructure group or your operations team, so forth, that have a lot of background with Docker, then they can, I'm sure, certainly help you tune and provision a host and your resources to run in Docker appropriately. Any bugs or unwanted features? There are some, I wouldn't call them bugs, I'd call them quirks of working with Oracle and Docker. One of them is that your configuration files aren't in the normal place where you would typically expect them to be. They're soft linked instead. So if you go to Oracle Home/DBS and you look for your password file or your SP file, you'll see that they're soft linked back to your opt Oracle Aura data /dbconfig/sid. So you would find those in a different place. So if you're running a script that changes or writes to files in the expected location, there's the potential that you could overwrite or remove the link and break that that configuration that is built into the Oracle Docker image builds. So that's a quirk. I wouldn't call it a bug. I don't know that I've encountered any bugs that are specific to Docker with Oracle, just the bugs that are Oracle bugs. I've been successful in running pretty much everything that I've tried to do in a normal database in a Docker environment. So I've run Trace File Analyzer, I've run Enterprise Manager, I've run Data Guard, I've run Oracle Sharding with 7, I beg your pardon, 3, 6, 7, 8 databases simultaneously configured over a private network on the system. So it is really capable. You can do a lot of things with it. It's just, you have to understand that there is a little bit of a layer of abstraction, very much like working with an environment on a virtual machine. You've got the hypervisor that separates your database somewhat from the underlying file system. So as long as you understand the slight abstraction that occurs between where Oracle would normally run and the operating system that it's running on, I think that you'll be good in that regard. Any other questions? Let me give you some links here. This is me. This is all my stuff, my LinkedIn and my my GitHub and so forth. Feel free to send me emails if you have questions or anything like that. Feel free to reach out to me over email. I'm more than happy to help you out with your Docker stuff and answer your Docker questions as they come up down the road. And feel free to jump out there and take a look at my GitHub and pull those repos if you'd like to explore a little bit of the other things that you can do, or some of the things that I'm exploring on Oracle and Docker. All right, and with that, I'll turn it back over to you, Yannis.
Okay, thank you, Sean. Thank you for all the information that you gave us, for all the questions that you answered. I hope that somebody from Slovenia also will contact you directly, maybe to exchange this information in 1 month. But we definitely saw each other tomorrow. You will have a game presentation. So I believe that this was, yeah, earlier than today, probably, or in the same time. So you need to go to sleep a little bit earlier.
I'm going to go to bed now.
Okay. That's fine that you could have opportunity to do this. So many thanks again, and see you tomorrow.
All right, great. Thanks, everyone. Thank you very much.
Thank you.